Good morning. We're going to look at the perpendicular bisector theorem now, which says that if a point lies on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So let's take an example of a triangle here. So we have C, A, B. Okay, let's take the segment, the line segment, AB. That's a line. And the perpendicular bisector of the segment, what does that mean? Well, it means we draw a line, so perpendicular bisector. So perpendicular means that the line is 90 degrees to AB. Let's draw the perpendicular bisector in. So this is 90 degrees, right angle. And bisector, it means it cuts AB in two. Now, if you remember, you were learning about midpoints and mid-segments yesterday. So if we draw a point X there, X will be the midpoint of AB. So in other words, length AX is going to be the same as the length XB. Okay, so those are the key ideas here. So, and that's what perpendicular bisector means. And what the perpendicular bisector says is that if we have a point on the perpendicular bisector, so let's take the point C, this point C, this is on our perpendicular bisector, it's going to be equidistant from the endpoints of the segment. The endpoints of the segment are going to be A and B. So what this tells us is that this distance is going to be the same as this distance. So putting that in mathematical language, let's look at what we have over here. What this tells us is that CD is perpendicular to AB. And what this tells us is that the length of AD is the same as the length of DB. In other words, CD is a perpendicular bisector. And what we then know is AC must be the same length as CB. So this is the perpendicular bisector theorem. Okay, let's go on and see how we can actually use this on the next slide. So here's an example for you. Find the value of x. Okay, so let's so basically we can see we have a right angle here and we have two lines here. So what this tells us is that the line in the middle here must be a perpendicular bisector. And what this means is that this distance and this distance must be the same. So all we're going to do here is we're going to set 7x plus 24 equals 13x minus 48. And that comes from the perpendicular bisector theorem on the previous slide. So let's just simplify this. So we take so we eliminate the x's on the left hand side first. So 24 is going to be 6x minus 48. And we're going to take we're going to eliminate the 48 on the right hand side. So 6x is going to be 48 plus 24, which is going to be 72. So x is just going to be 72 over 6, which is 12. That'll be our answer here. So all we do is we set the length of the two legs of the triangle that were given equal to each other, and then we solve the equation. End of problem.